Okay, then good.
Yes.
Very good evening, all the participants. Welcome back to the next session by Dr. Vignaraj Ananth. It is my pleasure to introduce the distinguished expert. He is a software engineer, expert in software engineering, machine learning, and data engineering. And Dr. Vignaraj holds a PhD degree in software engineering with a specialization in machine learning. With a remarkable academic background, Dr. Vignaraj has served as assistant professor in computer science department at Tyagaraja College of Engineering for 7 years. Additionally, he brings over 3+ years of industrial experience from HCL Technologies. Dr. Vignaraj is a prolific researcher with an impressive record of publications, including 14 journals, 16 international conference papers, and 33 patents to his name. He got 25 lakh research projects from central government in various research schemes and done mobile application for AIMS Raipur during his academic period. His expertise is in AI, machine learning, and data engineering. With this brief background, I will like to invite Dr. Vignaraj for this session. Sir, please, session is over to you.
Yeah, thank you so much, sir, for inviting me and giving me a great opportunity to deliver a speech on AI and IoT, where I've been serving as assistant professor from 2013 to 21 in Jharada College of Engineering. After a long time, 4 to 5 years, I'm back to this lecturing this lecture, and thank you for giving me such an opportunity for Dr. Nalikant sir as well as Rajesh sir for this opportunity. So I thank the SSN institution, principal madam Radha ma'am, and Satish Kumar sir, head of the department, for providing such opportunity. And thanks. For a week, it is a great process, and once again, thank you and for the great effect of Nalikant sir as well as Rajesh sir, because we have done a lot of FDP. We know that how much effort we put all those things from the starting till the end. So I know that thing. So thank you so much, sir. So with this, we will start presenting. Okay, I've shared my screen. Just check whether it is okay, so that let me continue with that.
Yeah.
Whether my screen is visible, sir?
Yes, screen is visible. Make it slide.
Yeah, I'll do that. I'll just go off the camera.
Right. We lost him.
Yeah, it looks like some
I think
internet.
we lost him. Yeah.
Yes.
There is net connectivity slow. I think very slow.
Now it's able to hear me, sir?
Yeah.
Okay.
You can start presentation, sir.
Yes.
Yeah.
You can keep the video off only, sir. I think internet connectivity is little weak.
Little weak.
Now it is okay. I'm keeping my video off already. My
Yeah, we
presentation
can see your screen. Now you can start presenting the presentation slides.
Okay. So for the topic today, just we are going to discuss about how AI
Sir, sir, we are not able to see the slides. We are seeing the mail actually. Yeah.
Okay, just a minute. Just a minute.
The entire screen, sir. Then you can.
Yeah. Now, sir?
Yes.
Yes, sir.
Okay, thank you.
Yes,
So,
perfect, sir.
yeah, okay. Now we
Yeah.
will start about the topic AI and IoT, how the AI and IoT have been influencing in animal interpreter system as well as in farming. So there's a lot of things, traditional work as well as traditional work as well as it's going on. Okay, so how it can process, and how the new technologies of AI and IoT bring into some.
Sir, is it possible to increase the volume, sir? You're a little bit feeble. Your voice is feeble. Can you increase the volume, sir? Yeah.
Right now, sir. Now, am I able to hear? My voice is okay?
Little bit better. If it can be much better, is good. Yeah. If it can be increased further, it'll be good.
Yes. I'll make something modified of my voice.
Yeah, it's very feeble.
Now, okay.
Yeah, now perfect, sir. Now that
Okay,
was good.
thank you.
Yeah, that
Thank
was
you.
good. Yeah, exactly. Yeah.
So,
Thank you, sir.
yeah, thank you. What will be the problem statement? Why we are going for AI or IoT helpful for animal intrusion system? So we know that animal intrusion, like if we put some paddy fish, something like that, and some of the animals or something may have some disturbance, maybe having some crop damage. All those things may happen. So animal intrusion farms leads to some crop damage and some economic losses. So as per the research, around 10 to 20% of total crop productions has been damaged due to this animal intrusion. And based on that, there is a huge loss, economical loss for the farmers in lakhs of amount annually, which creates some lot of issues, stress to the farmers as well as for the landlords for crop yield. So the farmer livelihood also, the income gets reduced because of that, and the production cost, all those things gets affected due to this animal. This is also one of the major problem for agriculture. So animal intrusion also. So the objective is to design a system, either based on AI or IoT, to detect and prevent some animal intrusion in farmyards. Okay, so maybe we'll be using some IoT techniques. Actually, what I have planned is I'll be demonstrating about IoT, what are the sensors, how it is going, and some sample demos on what will be the input output, as well as saying in AI, machine learning. Okay, so that's what I have planned to give a presentation for this topic. So the second thing is the animal presence. Okay, that how we will detect the animal presence using IoT is mainly based on sensors, cameras, drones, all those things we can able to predict the animal presence. And third one is animal species. We need to train some models, like it is AI based, purely a software one. How we can able to do some using machine learning, predict not only for the animal intrusion as well as for the farming, how the farmers get to act into that. Okay, the last one is giving some alert messages that they can help to prevent some measures to avoid those animal intrusion systems. So the scope, on the scope mainly we will be using about sensors which include motion sensors, pressure sensors, and camera sensors. Okay, to make a view about how the animals are getting into the action and how to solve those issues, and how we are going to give some alert to the farmers, which will reduce that damage to the crops. Or we can also say how this AI and IoT will help to yield the crop productions also. Okay, so there are some sensor technologies which already we have, and camera technologies like CCTV cameras, drone, etc. But in AI, when we use some AI algorithms, we'll be using some machine learning or deep learning algorithms. There are certain algorithms which really make some what we can say as accuracy to uh, gather all those predictions for farming, as well as identification of the species, what animal is just coming into the across based upon the training the model, like with includes of the perimeter of the land. So these are some of the what we can say as techniques which will help both in animal intrusion as well as in farming. So how the traditional solutions doesn't help animal intrusion. So if in traditional they'll be having some like fencing, Okay, fencing means which may have expensive for the farmers or time consuming, how immediately we want to put something, etc., and without the damage or without some of the harmful to the animals, etc. And the second one is trapping. So trapping also, it cannot be unpredictable, how we can able to do that. All those things, certain things are not effective, and ripples that may harm the animals as well as the environment. If some animals come and you throw something, all those things may happen. So it affects both the environmental habitat destruction also happened, environmental all those things stuffs have been happened. So this is something ineffective and may affect the whole system. So these are some of the traditional way they have done. Okay, but the impact of this is severe, like as I said earlier, like economic loss. But the most important thing is the environment impacts. Environment impacts, which goes to that habitat destruction of the entire environment. Even the soil erosion happens based upon that unpredictable situations. Water pollutions happen because of this. So it directly impacts the economic, directly affects the environmental, and directly which implements the farmers and the landlords, the owners of the land, the economic, the social, as well as the stress which happen for the humans. So to avoid, and we want to go something like innovative solutions, so that when we go for the innovative solutions, the technology comes into the place where it should not affect the we'll say as the farmers, the owners of the land, the persons who are there, working persons, as well as the animals, environment, and situation. The technology comes. So the technology mainly we have used, mainly we have been using sensors, cameras. That's one point. The third point is the data analytics. So we be getting all those data. How we are going to predict that? What are the animal species it can affect? Okay, what is coming? Okay, where the image processing also involved in that, and based upon that, how we are going to predict. Okay, the second thing is in the farming also, what type of soil is there, what crop can be put at that particular time during the period, and how much yield we can able to get it. Okay, and all those things, whether the water stops is there on the particular soil, based upon the graphical point, geographical point, all those things we'll be using the technology based. And non-ethical detection means it should not get harmful to the animals in ways of the sound which were being given once it comes into the land. Once the sensors come, some sounds are live which doesn't affect the animals as well as the environmental ways, something like that. And the integrated solutions, like multiple methods for to control the animal interruption from the crop, etc. Okay. So what we have some certain procedures and what we say, some algorithms or structure, architecture structure, in which we can reduce. I won't say we accurately we are going to reduce, but approximately we can reduce certain damages. Okay, maybe 10 to 20% may come to 5 to 10, something like that. We can have such ways, right? So just to make this, sorry, yeah. Um, Okay, so certain things may happen. So for one is the sensor technologies, okay, where the motion sensor, pressure, camera sensors we are going to take for the IoT. All these things will be based on IoT. And AI algorithms we have as machine learning and deep learning algorithms for certain procedures. And we have, even if you go for some allocations, we will be more mainly useful for some system architecture, like cloud-based one, how the computing may happen. Okay, all those things will be comes under the FOPO system. I'll be explaining the architecture also. Right? So right now we'll be seeing about that overview of what happened of IoT and AI, and that will definitely make sense how it works. Okay. So the first thing is we will right now we'll be going on IoT architecture. In that architecture, what are the possible ways to what are the possible models have been implemented with some sample demos and how it is for farming. The same thing for AI. Okay. So this is the way we will be going there. So first one is in IoT. Okay. The first one, the Internet of Things, right? So as we know that that IoT is something like we can make some software, but it's a network of some physical devices, right? From the physical devices or something else, right? We'll be embedded with some sensors, softwares, and some connectivity to exchange the data. So based from the device, we'll be getting the input and we'll be storing in some cloud database. Okay, from that cloud, we'll be using it for analytical purpose or prediction purpose, all those things by exchanging some data. Okay, so wherever we are going, definitely a cloud database is must to collect all those data. Okay, so this IoT is mainly based upon the physical devices. From that physical devices only, we are going to capture all those data, not like that software which we are using for AI models. Okay, so from that physical device, we're going to get some data. So what is the characteristics of IoT, which includes the connectivity, sensing, automation, and intelligence? This connectivity um, in terms means how the devices can connect to the network as well as mobile applications, how the alert system gets to that particular farmers or etc. And how sensing means how the data is collected from the environment. We will be using some pressure sensors, camera sensors, using the image processing. All those things will be capturing using some sensor. That's something to like a Raspberry Pi, all those things to physical devices, software. From that, we can able to connect all those data. Third one is automation. How the device can perform a task automatically. Like this is one thing. Like based upon that cloud data, it will give you how what to perform at a particular point and how this data can be going up and down, how this allocation alert system goes on, all those things. Automatic predictions as well as automatically it sends message to the farmers like alert message. So the fourth one is intelligence. Here it comes to the base where AI or ML algorithms come into place for predictions. So based on IoT, we'll be collecting some data, stored in the cloud, and some models will be there to capture all those images, like using image processing, what type of image animals are there, or what is based upon the sound, all those things will be capturing. We will train the model, and at the last part, it comes to a perfect output, like a deer is coming to your play, a deer is in your that means in that environment, like that, or if the rain prediction, how the rain, what about the rain predictions happen about the soil, all those things come into based on the data analysis. So this is the overall architecture, IoT architecture, how the system works. Okay, how the system works like that. Probably like just a minute, guys, just a minute. I just have some water. Yeah, sorry. Okay, so in this architecture, how it works means there will be three points where it comes upon the device administration, user administration, and security monitoring system, which comes for IoT architecture. Okay, first one is about the gateway. The gateway means getting the inputs, okay, from various ways like sensors or actuators. Actuator means nothing but electromagnetic device, okay, for how we are going to convert line into a motion, energy into something motion. Like that, we'll be getting various inputs uh, from the physical device, okay, which gateway is something about a software, getting the input and moving into some streaming process like the cloud gateway, cloud, or say stream data processor, or all those things. So data lake or big data is a database where all those data will be stored for prediction analysis or data analysis. Everything will be stored in a particular database. Okay. So what a person will be doing is the device management comes till here, till the database, all those things will be coming here, except this user business logic. So these are all the things a developer will use that, how we will be getting the data from all those sensors. From that sensors, it will be going to the cloud platform. The cloud means either it will be a AWS, cloud, or like Microsoft Azure cloud. All those databases are cloud one. We will be storing all those data. From that, the data processing starts. Okay, for particular time, what species come animals, or what rain predictions happening. All those data from that, you will be using certain models. Okay, so the data storage will be coming into this database. From that database, where we are going to use the models to predict it appropriately, not accurately, approximately, how much results can be able to yield. So from machine learning perspective or from the model, we will be training this data. If, for example, if it is a lion or a tiger or elephant, okay, so based on the species, we'll be using some image processing techniques to identify the species. So this based upon the sounds, everything. So this, all those things will comes under this control applications. So what is that control applications? Because that this is the one of the most important thing. The key functions is the control application is data processing. So it receives and processes the data from IoT devices like sensor reading, device status, and all of the information comes under this control application. Second is decision making. Based upon the data and the algorithms we have, it is used to make some decisions like using some logic and algorithms, whether it can rain can happen or a particular species is approaching your land. All those things it can able to predict. The third one is command generation. So based on this control, in this control application, we have the command. Command indicates, so like nothing but the alert message to the persons or farmers or any users, like this particular species is approaching, or there is a heavy rain predictions, or the soil erosion may happen, or crop this at this particular time, this quarter, we can use some species, all those things. It will be coming in under the control applications, right? So in this control applications only, a lot of scenarios like real-time content or predictive content, everything will be comes into the place. So this is one of the important places where all those data and applications with the result will be produced in this control applications. So this is the master database, right? This is where the logic and rules generated. So based on this, what happened, either using a web application or mobile application, a particular person can able to view, or they can provide some information to the user perspective. So this is the main architecture for IoT. Okay, IoT architecture. So where three important points. One is the inputs based on the sensors. Sensor means, for example, a perimeter, we need to know the perimeter of the land. On each corner, we need to keep some sensors. Okay, and from that sensors, what are the, we may predict some image processing techniques. Okay, how the animal should be there, or how something, what are the some related to agriculture, what are the things should be there. So all those data will be getting and stored in the cloud. So from the cloud sensor data, all those database, this application once this database comes into the computer application and the models comes here, everything it can able to predict based on this system. Okay, so this is the main architecture of IoT. Um, is it clear? Everything is okay. Shall I proceed?
Yes, you are clear. I mean, we can hear you. You can continue, sir.
Okay, thank you.
Yes, sir. Yeah.
Thank you. So this is about the AI, IoT architecture. Right now, I just give an introduction about the AI, how it goes there. Okay, then we'll be going about IoT commands, etc. So here AI, where AI comes is the computer performs the task. Okay, that software automatically performs the task, but it requires some intelligence, human intelligence, right? Like learning or problem. Right now, you know that ChatGPT or AI or even WhatsApp, Meta AI, all those things you might have used, right? So typically, human intelligence is required initially to develop a model, to develop a system. So once it happened, right, then it is an automatic process where everything goes into place, right? So this is what AI models comes into play. So it's a one-time implement scenario where all those data can be rolled out. Okay. So in AI, it helps for animal interaction, reduces the crop damage, all those things. But we need to use the IoT also to get the data and sensors, cameras. Okay. So, but the important point is here, not only it helps in animal interaction, but it helps really helps in farming. You know that robotics also comes from the place in farming. Okay, how the crop yields, how water, even the water level is low, how to spray water on time, everything where the AI comes using some algorithms. I have listed out some algorithms which is really right now they are using. Okay, we will discuss in the future slides. So predictive analysis is also happening for some property measures. Predictive analysis based on the different algorithms, okay, happening. So what is the techniques mainly they are using? So these are the four. I'm just giving the overview, but in depth it is like ocean, right? So I'm just giving the overview of that. So like machine learning and deep learning, NLP, something the computation is opening. But the main task of what I would say is machine learning is the algorithms where we are using some machine learning is to improve the performance over the time. They read the data, learn the data by modeling, but it improves the overall performance over time. That means the accuracy of the time. But in deep learning, we are using some n number of neural networks. There are a number of ANNs, artificial neural networks, convolutional deep neural networks to analyze the data to, or you can say as learn the data and predict some decisions like decision making. So these are some algorithms, specific algorithms that we have to improve and make some data-driven decisions. So the third one is NLP. NLP is something, but it's not relevant to here. But the output is like understand, generate some human languages, right? Like for example, right now, if you give some reports, automatically the Gen AI, the NLP process provides the crisp content. What it is in the document, a crisp summary. It can be developed and given. Okay, there we are using some NLP processing. Even if you give some data, it gives like this month, last year, this month this has happened. This month we are predicting about like that. So NLP process comes into place. And last one is computer vision. Computer vision is nothing but some visual data, images and videos we want to get into the place, and using image processing will be separating or segregating, or you can use some clustering techniques to group those things. So right now, this is what about the AI and the differences between AI and IoT I have given. But right now, we'll go in depth about IoT, how IoT in specific it's going here, both in animal interaction as well as in farming. So we will go slide by slide. So as I said, IoT, it gives a real-time monitoring. based upon the sensors, it gives some real-time monitoring. It provides some detection algorithms and preventions at some point of time, how the real-time monitoring happens, etc. Okay, so such things may happen. Sure. So there it plays some IoT plays a major role. What are the devices we are using in IoT? Main devices here is some sensors like motion sensors, where we can detect some animal movement, trigger some alerts based on that from the motion sensors. Camera, where we can sensors can capture the images from videos, enable identification. Based on this only, we'll be able to identify the species, separate species from camera. With collaboration with image processing techniques, we can able to analyze or separate some animal species. Acoustic sensors, main thing is to detect some animal sounds, right? Animal sounds will be will be having some animal sounds, right? Like bird calls or animal vocalization, etc. Last one is about the pressure sensors. Pressure sensors means like animal presence. Okay, by measuring the pressure on the surfaces, like based on the soil, how the stamp. And right now the park fund using some of the footprints of that tiger. All those things they have been using as sensors, right? So these are some of the sensors and devices in IoT we have been using. What is the communication? So once we have the sensors, it should be communicated. How the network communicate, all those things, how it proceeds over that. So for a main one is about that wireless communication, how the real-time data can be stored to the cloud. Okay, how the data should be transferred from data to the cloud perspective, and cellular networks. Okay, provide connectivity for remote areas, right? If there is some in certain areas we can't able to provide some networks, right? So how we can able to connect, but I would provide that, and mesh networks which communicate with each another with many devices. So there is certain network devices and communication happen in IoT. So as I said here, sensor, motion, pressure, and remote sensors. So how the system works? Okay. So there are certain things like we'll be having like automated alert system based on the IoT. Send some notifications directly to the farmers, landowners, if they are currently there, or wildlife managers, forest persons. Directly, you can make some based on the sensors. It gets the images and directly sends the messages to their mobile or something like that. So smart fencing means using some IoT, you can able to detect the animals from crossing their boundaries. Okay, elephant them going to the fence apart from the heretic fencing, like that. If you make some sensors, okay, then it gives some alert messages to the customer, to the farmers. Third one is animal tracking. Based on the IoT sensors and GPS, we can able to monitor the animal movements in the real-time data, how they are, where they are being there, and how based upon the drone sensing cameras and all those things are happening. Fourth one is habitat monitoring, means the environmental factors like the temperature, humidity, and soil moisture, and animal behavior, something like that, the habitat preferences. All those things may happen based upon that habitat, based on the environment. So certain things can help based on IoT. So the benefit is it improves the accuracy. When compared to the traditional one, it at least helps something to prevent some damages. I won't say exact fully, but at least approximate, improve some accuracy based on the real-time data, reducing the risk of the positives and negatives of the accuracy, and enhance the efficiency. Efficiency means based on the alert system as well as the smart fencing, it reduces the need for manual monitoring and prevention. So this certain things provide some, it helps, really helps the efficiency and safety. because in tradition, you know, that man and persons gets into that act, but it really what we can say as reduces the human-wild conflict, which creates some potential threats. Okay, and last one is the main important point, um, which really helps for us in IoT and AI is for data-driven decision making. So, based upon the data analytics, valuable information we are getting from that valuable information, we can go for some prediction whether certain things can happen, or animal management, or certain decisions, conversation, how the assumptions may have predictions, or animal or copy, everything that based upon the data from the past, the present scenario can also happen. Okay, so real-time monitoring, the real benefit or other thing is the real-time monitoring. Okay, continuously stores the data 24/7 that helps the animal movements as well as the patterns, really helpful for us, and reduces the cost associated with manual monitoring, putting someone a day and night to monitor, and it is also security issues for the corresponding person, and certain things and damages it be getting reduced based on this animal. So where this IoT is used mainly in agriculture and wildlife conservation, some managing some wildlife populations, etc. Forestry, which includes how this preventing some damages in certain points, or even some fire after forest fire. How to use all those things can happen. And range land management means like creating some patterns, right? The pattern scenarios and all those things can happen. So these are some of the applications they have been using. So the system, as I said, what are the devices how we can be using? So sensors, as I said, motion, pressure sensor, and camera sensor will be using. Second thing is microcontroller. Microcontroller means like Raspberry Pi. This is the main thing we have been using, or we can use Arduino for software. From the device, we can get some all those data from the sensors to database. So communication, we have the Wi-Fi or cloud platform. We have either we can use AWS or cloud, Google Cloud or Azure for storing the data. So this is about the IoT, a simple way, simple tool, data as well as the cloud platform with some mobile indicator. We will be telling a CTL tool for data transform. Okay, and based on that, we'll be getting some information. So the system components, as I said, motion sensors is most important. While we are installing that, we should install based on the perimeter of the farm to detect the animal movement. The camera traps install at strategic locations to capture the images. Third one is acoustic sensors to detect some animal sounds, and the gateway, which I said, that collects the data from the sensors and transmit to the cloud. In the cloud platform only, we will be doing some all those analysis patterns and the triggers, alert triggers that enables in the to the farmers or etc. So basically, input is given, logic is being used, the output as a simple way of senders like sending some alert means it directly goes to the person using some mobile applications, right? Notifies about even to the forest rangers, all those things, right? So this is a simple way to do that, but maintaining all those records, analysis takes some huge time, right? That's the important logic we have been using. So this is the system overflow, how the sensor deployment is happening from the sensor workflow, how the work is happening. Sensor, from that sensor we are getting data collections, um, animal movement, images, sounds, how the data has been transferred. And this is what we will be telling us technical terms, how in IoT or AI, this is what we technical terms we are using: data transmission, data analysis, alert generation to the mobile, and last one is notification. So I had given some sample scenario. For example, if any animal comes into that land or something else, how it triggers. So motion sensor triggered when the motion sensor detects some animal movement along within the perimeter of the farm. Okay, so once any animal comes, right, the camera captures an activator to capture an image of the animal, and as well as the acoustic sensor, sound sensor also detects the sound. Okay, the next one is that this all those image as well as the sound transfers to the cloud. So in that cloud platform, where already a predefined model is built. So in that model, based on the analysis of the images, the sound, with image processing, it will be different like a deer sound or a rabbit or something elephant sound. Some analysis has been happened and make a model. So once this data comes, okay, so the cloud platform analyzes the data, detect what is the pattern. The pattern in technical term means what we'll say as procedure, which animal, how we are mapping each animal. Okay, for elephant means it has some trunk. Okay, then 4 legs, like that. We will be having some pattern. Animal each species we have some patterns. Like all those directs the patterns, identify that it is a D. So once it is identified, everything will be happen in a fraction of seconds. So automatically alert generated from the cloud platform, it generates an alert and sends to the mobile application. So at the last, the farmer notified what is the its potential deer intrusion. So he can do the further process. Okay, this is something like sample. This is what it works. The IoT works and caption of the images. Okay, so how it helps in farming? Based upon the animal, everything is same, right? From that input, from the sensors only, we are taking all those data. But in the control application, nothing but a database, we are creating some models based on each scenario. Okay, it won't be a generic one. Based on the each scenario, we will be providing it. The first one is like based on the real-time data. We may be getting what is like. What is the real-time data, okay, what is the site or soil conditions, what is the crop health, what is the weather, and all the other impacts that directly relates to the crop yields. So how we will be getting all those things is there are certain sensors, additional sensors, how we are going to monitor it. First one is soil monitoring. So based upon the soil, okay, soil monitoring sensors means like it's also, it will be in the surface where it will measure the moisture levels, and based on that it also provides some optimized irrigation schedules, how and when we can be able to do the irrigation process, how to start all those things. But based on sensors, we will be using some Raspberry Pi or Arduino, all those things are softwares, right, for that. The second thing is the soil temperature. Based upon the temperature also, the farming, like what planting times, what when can we plant some trees or something, some planting scenarios based upon the soil temperature, which won't affect the yields. And third one is pH. pH means what the fertilizer and other inputs need to be there for the particular soil. So if we get that data from the soil moisture sensors as well as the temperature, definitely this pH value comes from the place where we can able to get it for precise farming. So the second one is crop monitoring. The crop monitoring means like um, um, what what about the health of the crop? What is the growth and development where enabling the farmers to detect issues early. So how we'll be getting the data means once the crop has been started building like that, based upon the sensors of the soil as well as the crop, it gets the data. So how it gets the data means we need to train the model. We need to train some machine learning or algorithm. Based upon that, we need to train the model. Like this crop, if you put something like that, even sugarcane like that crop, what is the height, what should be that middle level language in 1 month, or how it should be there, what is the watering procedure, all those things we need to train the model. Once we train the model, only at every particular point of time when the data comes into the place, it will map with their trained model. Or at 1 month, this is the height, this is what happening, or this is the growth of means, then it will easily predict whether, oh, right now it is going in a good way. If there is something error or something issues being there, so yeah, something issues being there, it immediately give the value. Okay, this is about the crop sensors. Second one is about the image analysis. Using some images, cameras and drones also, we can able to capture the crops, the image, and based on that, we'll be already the trained one. We will be using some science for disease, or we want to put some pest or something like that for fertilizers. Also, we can able to do that. So yield monitoring, as I said, based upon this sensor, in a real time, we'll be getting every week update, every 2 weeks once update, like how daily water level of that soil, how it is growing, all those things, including the harvest schedules, also can able to provide the input. So weather monitoring, it is a pre-point one about the monitoring the temperature, humidity, the speed, so that the farmers can plan according to or the forecasting, which really helps for them. But the important one is, apart from soil or what you say is crop, important one is irrigation management, where uh, this is the main part which really helps for the farmers or some persons, right? Using the sensors, it provides some schedules. At this particular point of time, this crop, if you put, then based on that, how the yield will grow, whether the profit or it can be done best, some what we can say, some crop can be done based on this, or all the scheduling can be done. So based on this now, it can deliver some water directly to the roots of the plant. So if the water level is too low, it gives a message, and based on that, a robotic or something like that, or even the camera, the drones can water the crop directly. So this is one of the major important thing which really helps. So, and right now it is also upgrading in many countries, even in India also. So this is what something livestock monitoring means, like what is the health and behavior, and helps really help for feed also, feed levels of that, like pesticides or fertilizer to be used. But what are been using the data analytics again? Without that, we can't able to predict anything. Okay. The data integration, integrate the data from various sensors, farm operations, etc., and using the machine learning for identify the patterns and making predictions. And third one is about the decision support. So they can able to predict what can be happen at what time. Okay, how we can use something to main cause for decision support, how it can be used out, right? Some analytical purpose also it can be done. So, as I said, some components, maybe the soil sensors, weather stations, crop sensors, the drones for capturing the aerial images. So, all those things, these are the inputs. These are the 4 inputs we will be giving to the gateway, right? Which I showed you in the IoT architecture. So, based on the gateway, all those information comes, and the cloud platform analyzes the data, detects the pattern, and provides some valuable input, which in turn gets the mobile application for the mobile app messages, alert messages to the particular persons. So this is what the system flow works: sensor deployment, data collection, data transmission, analysis. Okay, this analysis part I will show some algorithms how it worked on. Okay, so and recommendation, and based upon the algorithm which we have provided, only the recommendation comes. What about the irrigation, the fertilizer, what is the pest control, and harvesting happens, and all those things it comes under the system workflow. Okay, so these are something really happening based upon the IoT devices. So this one's about that sample scenario, which I had said here, right? In the technical terms, I have been saying, like 24 hours happening, the crop sensors, once the pest infection in the harvest happens. So it just gives the control measures to the farmer. okay, what is happening and what can be done, right? So based on that, the benefits, if you take about the benefits, like it increases the crop yields, it gives some prediction, data-driven decisions, and based on that, the crop yields, if there is any infect disease at the early stage, it can be reduced. That makes us to make the crop yields increase level and reduce the water consumption. Then and there, if you want to put some water, it gives the soil, right, when need to be done, and all those things can happen. Then improve the crop health based upon that prediction analysis, the sensor about the disease, yearly analysis of the disease can help to proactive measures, reduce the chemical use. So based on that, the pest control of fertilization based upon the soil as well as the crop health, the crop monitoring, uh, we can use that level of the pH for fertilizing, what is the chemical use, all those things. Then increased efficiency. Increased efficiency means like farming the task, increasing efficiency, and definitely reducing the labor cost also. So these are some of the benefits we have been using here. The same thing, efficiency, sustainability, and the data-driven decisions also. Okay, that means data-driven decisions. The main use is reduce the risk of human error. Okay, somehow we have some right, like that. It reduces the risk. That's it. Not fully, but approximately. So these are the things we have been using in IoT. But what the AI does, everything the same here. What getting the input, sensors, cloud gateway, all those things. But what AI does here is uh, creates a model, create an algorithm to prevent the animal intrusion, and as well as provide a good knowledge for farming. So these are the things where AI comes into the place. That's nothing but an IoT device as well as the AI, both combinedly we can able to use it, right? That's what I'm trying to say. So in the animal reduction, AI powered computer vision, right? The same thing, we can capture that image in the real time scenarios, etc. And second one is the important one is the 2, 3, and 4 is the most important one, like species identification, where AI algorithms use some machine learning algorithms, image processing techniques, algorithms. It identify the species and detect the animal more appropriately, right? Enabling some target response more appropriate in terms we have some algorithms to identify, to create what we say as, detect some species, and the okay, maybe this type of animals may be harmful, this is not harmful, like that it can able to say, like any species, also a snake also a species, right? A rabbit also a species. What can be done based upon these species, right? So it can able to identify, cluster the data, harmful and non-harmful, and based on that provide some thing. Third one is behavior analysis, means analyze the animal behavior, detecting some anomalies, some like elephant into the destroying this the way it comes in destroying the some crop on yield. So it detects the behavior of that and predicting the potential threats. Fourth one is based on that, the alert system notifies the farmers, ranchers, or wildlife for potential institution. And last one is without creating a harmful to the animals or something, how the lighting or fencing sound can be for some animals, right? So these are something, but the main part of the AI is to do some species identification as well as for behavior analysis, right? So in detail, if you go, there are certain things like AI powered behavior analysis, which I was telling the two important things. So anomaly detection. So certain algorithms are there. How the animal species can be detected. Anomaly detection means what's the threat level of that unusual behavior. If an element comes in normal way, walks on both, that is a separate thing. If a huge, it's a lot. If there are a number of elephants are coming and it's just going and destroying something, so it directly predicts that. So these are something an algorithmic way used to capture the image and sends directly to the cloud algorithm to predict what is the range. Okay. Then what about the predictive analysis? The predictive analysis means like what is the animal coming, how we can able to take some measures to prevent those institutions. Like if they are coming, what is the advanced way to prevent that? So something the predictive way it can be done. So alert system sends alert to the particular persons as well as specific needs to preference to the users, right? So what type of algorithm, I mean, machine learning happens, right? Happens maybe that supervised learning algorithm. I'm going in depth of algorithm, in ML algorithm, what can be done. So I am saying about the supervised and unsupervised algorithm for that. In that, supervised learning algorithms can be used for some animal classification. Some future extractions algorithm can be used for accurate and real-time classifications algorithms. So this is something general, right? So supervised example classification, regression algorithms you can use, and supervised. This is all something we are going to create a model. Okay, that's the main perspective. So where the image processing comes, right? There are two things in image processing being able to do, that is object detection, right? That is something algorithms or some codes are there, and image classifying. Based upon that, we can classify the image into some species, etc. So from that will be the input, the other input. One is the real-time data. The other thing is that predefined image processing data, like object detections or image classifications, where you can able to detect something. Okay. So based on this based on this object detection image classifications only, the ML algorithm can be able to train the model more accuracy. Okay. So what is the classification? So these are the algorithms where they have been used in certain models, okay, for both for animal intuition as well as for farming. Okay. First one is the random forest RF algorithm. Is a pre-owned algorithm, early detection of algorithm, where we can able to censor the data, can be used to classify some animal species from the sensor data. Second algorithm is about support vector machines used to clarify some animal species or detect anomalies. These are some of the algorithms which provided more accurate, more appropriate results. Okay, if 100% it means at least it may provide something like 92.5, 90, 91, like that. It can provided some results, right? So the third one is the K nearest animals can be used to classify nothing but some clustering techniques, okay, which is can be harmful or non-harmful animals species which can come to happen. So these are some of the classification algorithms, the models which have been built in machine learning. The second one is object detection. These are something where depending on machine, image processing comes into that. Some algorithms, these are the algorithms they have done the literature reviews. One is YOLO algorithms. You only look once. So this something like algorithm can be able to detect animals. Some other is single shot detector can be detect, and faster RNN. RNN means CNN means convolutional neural network can be used. These are some of the algorithms they have been trained. Some models. These are some of the models, right? And they have using some algorithms from the time series like auto regressive, integrated moving average algorithm, long shot term algorithm to forecast the animal movement, or gated recruitment unit algorithm that also used for animal pattern, how we are tracking that, how we have been tracked earlier, how we are using that, right? And fourth one is anomaly. Anomaly detection means like in SVM support information also we are using that, deviation of the algorithm, deviation of the species, something abnormal behavior, okay, some local outlier factor to detect, okay, isolation for us. So these are some of the models, or we can say as algorithms, which are being implemented to develop a product. So as a product, we'll be not using all those algorithms, but each algorithm provides a specific accuracy. Okay, but these algorithms will provide the result. For example, if I want to develop a product from random forest, from YOLO or SST or CAN, we will be able to detect that algorithm, I mean images. We will be giving to the classification algorithm either for random or a support version input with the input of any one of the algorithm from the time series or anomaly detection algorithm. So at the last, for the classification, we have the three inputs. We will be training the model. From that training the model, it compares with the real-time images and provides some predictive analysis. Right? So this is how this product or model works. Okay. So I given some demo. Okay, how real-time it comes into it. So what will be the input and what will be the output? Okay, the input features means like sensor data. Okay, from the motion sensor, 0 and 1 means 0 means it means presence and 1 means it's absent. So presence and absence, it gives the value in RGB values, zeros and ones. Okay, this is the way the sensor works. Okay, so based on the sensor input, the image, okay, from the camera traps, and third one is the environment data, the temperature, humidity, and weather. So these are the three input features we are giving into the gateway. Okay, so the output is two things. One, whether the animal presence, okay, whether the animal is present in the field correctly or not, and what is the species. Example, deer or rabbit or boar or something else. What is the species? So this is the input and this is the output. So what does the machine learning algorithms we may use is either we'll be using some conventional neural networks for image classification and feature extraction. We will be using some random forest for the data and environment data classification. And third one is the gradient boosting. What does that means? To optimize the results. Okay, based on the CNN and random, we are getting both the input. Okay, this GP algorithm provides some optimization. Optimization means in how much seconds, how much nanoseconds you can able to provide that results. Certain things, right? For example, if you write a code, right, 1 to 50 numbers you want to print it, right? Anyone can print 1, print 2, print 3, print 50. Some person may use for loop or if loop or something looping structure to provide an easy way, right? So certain things it provides, the GPU provides some optimization results. So based on this algorithms, we are going to train the model. The technical term is model train. A data set, we got it from the sensor data, image data, and environment data. We are going to pre-process the data, normalize and pre-processing for the training. Based on that pre-process means in the image, we have been using some Weka tools. Directly tool, we can also use some Weka tools, or even for Python coding also can use it, where some data may be missed or some data may not be there, irrelevant data fields may be there. We need to pre-process all those data for training. Once that is done, then that need train that pre-processed data with the machine learning algorithm from the CNN, random forest, GP. So once all those things come, then we need to check the model evaluation, the sample data, how it performs. The performance means we need to see about the accuracy, precision, recall. Mostly we'll be saying as actual and estimated one, right? Estimated, maybe if you want to build a home, what is the budget? 75 lakhs or 80 lakhs, but it may come earlier. 70 lakhs may be completed, or it may go for above 80 to 85. But that also, if less also, it is the disadvantage, and more also disadvantage. So what will be the accuracy level, precision, recall, all those things we need to train the model. Okay, so once it's done, the model will be deployed. So sensor integration will happen based upon sensors, real-time data processing, alert systems, whether the animal is present or not. So directly it sends the message to the farmers or mobile application nodes, or even if you have some fencing techniques, it provides siren alerts to even to the farmers as well as to the species. Okay, so this is what a model will be generated. So next one is about the how AI informing. So as I said, how will be there means crop monitoring. Okay, as I said, that based upon the sensors or even from the drones or the satellites, where we can able to identify the health, growth, and the development of the crop. The soil analysis, how the soil condition, detecting the nutrition deficiency, and optimizing the fertilizer how it can happen, certain things, how it may happen. And third one is um, what I can say is weather forecasting, okay, and how the disease management can happen, okay, how to control all those diseases, pest, all those things we can able to predict that earlier. So there we can AI come do in farming. So it provides some yield predictions, predictive analysis, right? And the third one is the farm to table supply chain management. This is most important thing where optimize by reducing the food wastage or improving the efficiency to produce more from the farm to the table. Table means the productions outlook, the how to what we can say to sell it, right? All the supply chain management, AI produces more effective in farming. Okay, so for this, what will be the input? For animals, we have provided the input. For crop yield, what will be the input? So the input will be like weather data like the temperature, humidity, or wind speed. All those things come to the data. Then the soil data, where the pH level of the soil, the nutrition level of the soil, okay, the moisture. These are the data from the real time. The crop data like a type, growth stage, and the health status of the crop, and the image made by the crop. These are some of the input. Not all the data will be given, but at present, at that real time, what we need, we can give it as an input. Okay, so the output means a predicted yield of crops. What will be the prediction can happen, yield can happen. All those things will be the output. So here, what algorithm we are using is random forest because it provides what you can say like enable method provides more accurate results when compared with other algorithms like decision tree or like you can say as a really algorithm what we have seen, right? So something it provides something even for classification algorithms. It provides some good results, right? And the CNN is used for analyzing the image. So how you're going to train is collect the data of the weather or soil or crop and pre-process it, train this model with random forest, okay, and CNN models, and do some metric how that model gets evolved, okay, how accurately it gives some inputs, output also. So the model deployment happens based upon the AI, API means application performance interface, how to integrate the model with the farming software, the cloud deployment where the data can be given, a farmer interface, user-friendly interface for the farmers to provide the data, receive the predictions. But all those things will happen for prediction based upon the historical data. So in this soil, previously these are the terms they have provided at this point. This weather forecast has happened. So whether at this time or this quarter, this month, whether it can provide or not, whether what crop can be used for yield purpose. So based on all those historical weather, only real-time proactive measures can be happen. So this is something based upon the analysis or prediction. This works. Okay. So what is the benefit of that is, of course, efficiency is improved, that AI can automate the task, reduces the manual labor, optimize resources, improve some accuracy with the high level reducing the risks. Decision making, okay, based upon the data, cost efficiency, improve sustainability. But the main thing is how much the crop gets reduced, right? The reduction still at present get is reduced. The farm productivity is increased by 15% of the current one, and the income and the resources. These are some of the external factors, but the main purpose is what crops can be used at some particular point and how the farmer gets benefit. So these are the certain things they have been really working on that, specifically how to yield something like uh, how to attract and how some crop damage or the without any harmful to the animals, and the predictability level how it increased, right, based on AI and what. So At the last, what we can conclude is, even if we get some data, real-time data or all those things, what model we are going to prescribe, right? How we are creating the software, what algorithm we are using, okay? It takes time, but once the model is set out, okay, it will be very easy for the farmers or anyone, some persons or for any farming to get automated one. Okay, so this is how this AI and IoT helps for the animal detection as well as for farming. Okay. Yes, with this, I just conclude my lecture speech about that introduction system. Okay. So anything you want to ask or anything, sir?
Hello.
Yeah.
Yeah. Good. Participants, if you have questions, you can. Hello.
Sir, I have one question.
Yes, sir.
For the input to these machine learning models in case of animal intruder system, there are different type of sensors are there now. Some are capturing images, some are capturing sounds,
Mm.
and some are, so I think some pressure sensors are there. So how you are giving the data to these machine learning models?
Sir. Yeah, exactly. So this is what the architecture. So the how we are giving is based upon the sensors, all those data. If you use some data, it will be like Excel format, right? So I don't have that right now. That data sample data I don't have right now in the system. Okay, how the data comes means, for example, based on the perimeter, like a GPS location, if you are sharing now. So like that, this data comes like this is the time, this animal footprints, animal some unbehavior movements are there in the farmyard. Like that, we'll be training some data like movement and movement, right? Zero and ones. Like that, we'll be giving the data. How we are going to give it the data means directly to some cloud environment, AWS. We'll be directly storing the data. This sensors directly provide the data alone to the cloud, AWS or Azure, whatever it may be. From
Okay.
that model only, we are going to give the input in the form of Excel or a CSV file, something like that, right? The image or something like that, we'll be giving in the form of certain format like CSV file or Excel file. Based on that only, this algorithm comes into place, map that each data, what is the species, like in CPU, how we are going to do that primary, secondary, like memory point of view, like that, it sends that and provides the output. So all those data, for example, that means I need to create a model. Once I create a model, if I type something or the sensors give means from the Raspberry Pi. This is the word we are using, the Raspberry Pi. From that Raspberry Pi tool, directly flow to the environment.
Thank you.
This one.
Any other questions from participants? I think we can wind up the session. Thank you, Dr. Vignaraj. So very,
Thank you,
it
sir.
was very informative, and you have shown us how the IoT architecture looks and one practical application of these
Yeah.
machine learning models on agricultural farming. So very informative. Thank you very much for your time and sharing knowledge with us, sir.
Yeah, thank you so much for
Thanks, sir.
giving time for sir, giving such an opportunity for me to deliver such a speak. Thank you, SSN institution, and Ali Khan sir, as well as Rajesh sir, for providing such an opportunity for me to deliver.
Sure, sir.
Thank you so much.
Thank you, sir. Thanks a lot.
Thank you, sir.
Good night, sir.
Good
Thanks,
night,
sir.
sir. Thank you.
Yeah,
Thank
good
you
night.
all.
Yeah. Participants, yeah.
So